Let's look at the 8th question. So in the question, we are given two frictional walls, and the condition given is that the ladder is just about to slip. So we can assume that its limiting case on both the walls, that is, friction is equal to mu times the normal in both the cases. This angle is theta. This has a frictional coefficient mu1. This has a frictional coefficient mu2. So we just take this surface to be 2 and this surface to be 1. There's a normal force acting here, N1, a frictional force acting upwards, which we'll just write straight away as mu1 N1 because it's the limiting case. There's a normal force here, M2, and a frictional force towards right, mu2 M2, and of course there's a gravitational force acting at the center, Mg, and this angle. Then this is theta, so this is nothing minus theta, so this is theta. So you can have two equations for force being 0 in the x and y directions. That will give you N1 is equal to mu2 N2 and N2 plus mu1 N1 is equal to Mg. This can be written as N2 plus mu1 mu2 N2 is equal to Mg. Substituting N1 from the first equation, which means N2 is equal to Mg by 1 plus mu1 mu2, and N1 is mu2 times this. So N1 is equal to mu2 Mg by 1 plus mu1. Right. So from this we can actually see in the options that they are given such that mu1 is 0, mu2 is not 0, and those are the options given. So we'll have to take care of all equilibriums then, not just translational equilibrium, but the rotational equilibrium has to be 0 as well. So we can write two equations for rotational equilibrium, one about this point and one about this point. About the lower point, the equation will be, if this is L, this is L sin theta, and this is L cos theta. So the torque about this point of Mg will be Mg L cos theta by 2, and it is in the clockwise direction, and that will be equal to the sum of these two torques which are in the anti-clockwise direction. So N1 L sin theta plus mu1 N1 L cos theta. Similarly, the equation about this point will be, for Mg it will be Mg L by 2 cos theta is equal to, now Mg has a torque in the anti-clockwise direction with regards to this point, and N2 has one in the clockwise direction, but mu2 N2 is in the anti-clockwise direction, so that will have a negative sign. So this is equal to N2 L cos theta minus mu2 N2 L sin theta. And mu2 N2 we can directly write as N1. So this equation is N2 L cos theta minus N1 L sin theta. We divide by cos theta this whole equation. What we get is Mg L by 2 is equal to, or L also cancels, Mg by 2 is equal to N2 minus N1 tan theta. So from that I get N1 tan theta, which is in a lot of the options, that's why I'm doing that, is equal to N2 minus Mg by 2. And what is N2? This thing. So Mg 1 by 1 plus mu1 mu2 minus 1 by 2, which is Mg. So the denominator is 2 times 1 plus mu1 mu2. 2 minus 1 plus mu1 mu2 is 1 minus mu1 mu2. Or Mg by 2, 1 minus mu1 mu2 by 1 plus mu1 mu2. Right? Now let's start looking at the options. First of all, we can just see from intuition that mu2 cannot be 0. Right? If mu2 is 0, then there is no way that this will stay in equilibrium, because this side will have to slip. Right? If a more rigorous way of looking at that would be, if mu2 is 0, then n1 will be 0. Right? If n1 is 0, then mu1 n1 is 0, which means about this point, the only torque acting will be that of mg. So it cannot stay in rotational equilibrium, means it cannot stay in equilibrium. That is the rigorous way of doing it, but you can just tell by intuition. If the lower wall does not have any friction, there is no way it is going to be able to support it, right? The weight will drag it down eventually. Rigorous way to see that is, if mu2 is 0, then n1 is 0 and mu1 n1 is 0. Both these are 0, that means mg has a torque. So mu2 cannot be 0, that means we can eliminate option B directly. Right, let's look at all the options. Option B is false. Then option A and option D suggest that mu1 is 0. So if mu1 is 0, this equation becomes just mg by 2. So if mu1 is 0, n1 tan theta is mg by 2. Right. So option D is correct, and of course option B is false because n1 is not equal to n2. They differ by a factor of mu. So A is false and B is true. Let's look at option C now. If mu1 and mu2 both are not 0, then n2 is equal to mg by 1 plus mu1 mu2. n2 is equal to mg by 1 plus mu1 mu2. This is a true result. So C is true. Which means the answer to this problem will be C and D. The tricky one in this case, in my opinion, would be option B, because if you just look at this equation, if you look at the options and see that they're asking for n1 or n2 tan theta, and you get here and you see that if you put mu2 is 0, you get n1 tan theta is mg by 2. So you'll in a hurry might put option B as correct, but it's false because n1 would just turn out to be 0 in that case. Thank you.